fellas. Thank you all for coming. Stacy and I are really excited. I'm Patty DeBartolo. I am the faculty director of the sciences here at Smith, and I'm also a professor of psychology. And I'm going to introduce the series to you today. It's hard for me to believe, I kind of need to picture myself, that we're here, it's launched. Stacy and I have been working on the series probably for over a year. I think it was a Sunday last fall when I was reading the New York Times Magazine, and on the front was a cover story some of you may have seen, Why So Few Women in Science. And I read the article and it made me angry and helped me feel kind of compelled to do my job here as faculty director at Smith. And that probably would have just passed, except that social media got involved. So I happened to be on Facebook not long after, and Stacy posted a comment with the article saying, gosh, this made me mad, and women's colleges probably have a really important role to play in all of this. And I wrote back what I probably thought was an innocuous comment, something like yeah, and she said, let's have coffee, and I said, yeah, and then next thing you know, we were planning a series, and we're going to have a faculty development workshop in May, et cetera. So we've been working on this for quite some time. We're really excited that it's about to launch. It is a joint venture of the Science Center, the Career Development Office, the lecture committee here at Smith College, and there have been many people, probably too numerous to thank, for helping us to pull this together in small ways and large. So you will see there are posters that have all 4 of our speakers. We have 3 this coming up spring, so keep an eye out for further announcements. And I'm going to yield the floor to Stacy, who's going to introduce today's wonderful speaker for us.
Thank you. And yes, I want to echo that I can't believe it was a year ago that we had these conversations and Facebook rants that resulted in this. So truly very exciting to have this be finally launched. I do want to thank Joe O'Rourke and the committee that helped to fund this. There were many, many faculty, as Patty said, who along the way have really engaged in very rich conversations that have resulted from a very initial conversation that we had. So a shout out to some of the faculty who really have helped buoy this project and make sure that we actually made sure that our Facebook rant came to fruition. And certainly thank you to Patty and the Clark Science Center for rolling up your sleeves and saying, yes, let's do this. This is a really important and critical conversation to be had, but all the more important for Smith to be really engaged thoughtfully in this question of women in STEM and the persistence of women in STEM. So, and also thank you to Kathy for being our first speaker in this really fabulous series. Now, also bear in mind that the non-scientist is doing the introduction of Kathy, so bear with me as I muddle through much of your research. So, Katherine Aidala, as many of you know, is a faculty member in the physics department at Mount Holyoke. Her specialization is condensed matter physics and nanoscience. As an undergraduate at Yale, Kathy was a double major in applied physics and psychology, which I thought was quite wonderful. She went on to graduate school in applied physics at Harvard, where her thesis was on imaging electron motion in magnetic fields in a 2-dimensional electron gas. All right, we have fans. This involved designing and constructing a cryogenic scanning probe microscope. Kathy continues to focus on scanning probe microscopy as a flexible technique to study a variety of nanoscale systems. She is a recipient of the prestigious Presidential Early Career Award for Scientists and Engineers, as well as the National Science Foundation Career Award. Kathy received the Cottrell College Science Award for beginning faculty members from the Research Corporation for Scientific Advancement. Her research has been published in Nature, Physics, Physical Review Letters, and Nanoletters. At Mount Holyoke, Kathy teaches Physics 216, a calculus-based introduction to electricity and magnetism, introduction to analog circuits, advanced quantum mechanics, and women and gender in science. So, without further ado, Kathy, thank you.
So thank you for that introduction. Thank you for inviting me to be here. I am happy to get this series off to a great start with attempting to answer the question, why aren't more women in science? Of that introduction, I would say the relevant things to this particular talk are double majoring in psychology, which I think gave me some of the initial interest and a lot of the vocabulary to go and take psychology of gender and developmental psychology, and to take a course on evolution of human behavior, and to really think about these questions. I would say I was an undergraduate who was fairly oblivious to some of the problems that women faced in the sciences. I thought we could just wait and everything would fix itself naturally. So that prompted me to think a lot more about these issues. And then the fact that I was at Harvard in 2005 when Larry Summers made his infamous speech where he suggested some provocative explanations for why there weren't more women on the faculty at Harvard. And that actually spurred Harvard into a lot of action to hold various events and seminars and chances for everyone to talk to each other about women in science, which sort of refreshed me on a lot of the literature and helped me think more about the problem. So when I can, I teach a gender and science seminar at Mount Holyoke. And my attempt today is to summarize the semester's worth of material in less than an hour. So with that said, we'll get started. Why aren't more women in science? The very first thing you need to do when you have this conversation with someone is make sure you're asking the same question. And part of my goal in the class and in this is also when you find yourself in this conversation, whether it's with someone who's adversarial or someone who's very friendly, to arm you with sort of what do we know right now, what's some of the most compelling evidence. There's a lot of stuff that's contradictory that different people sort of favor because it speaks to them personally. And there's a lot that we're just still figuring out as to what we can say, but it's not an easy question to answer. So what are the actual questions that you're trying to answer? Because you get different answers depending on the question. Why are there so few women physics and computer science majors in college? That's a question I care a lot about because I teach physics majors in college. So I am going to lean a little bit towards that interpretation of the question, I warn you. Why are there so few female biology professors? It's a different question. Why aren't there more men in nursing? Is that actually the same question as what we're trying to ask about why aren't more women in science? Are we really asking the question, why do fewer women score in the extreme high range on the SAT math? Because when you read papers, that often seems to be the question they're trying to answer, or at least it's a variable that they're using to answer a much broader question. So a lot of arguments come from scores on the SAT math. Are we really asking why aren't there more women in leadership positions in general, right? When you look at each one of these questions, you might immediately come to one particular explanation that makes more sense to you, but they all end up being relevant to the entire conversation. So it's easy to get confused in your conversations with colleagues, with friends, with enemies, because you're trying to figure out what's going on. So what are we doing here today? What are the statistics? How are the different disciplines within the sciences different? That's really important. What are the commonly heard explanations, and for what questions? And then what is the most compelling evidence? At the end, I do want to talk a little bit about what's going on at Mount Holyoke. We can talk a little bit about women's colleges, and I want to leave a lot of time for questions, and I'm happy to stay for as long as you want to talk about whatever topics I haven't really covered in this, because I can't cover everything. So statistics and the different disciplines. Some of these graphs are outdated because one of the hard things to do is actually find the scientific fields broken down the way I want to try to think about them. So this one only goes to 2001. We have all fields. This is bachelor's degrees earned by women in selected fields. So women increased the number of bachelor's degrees they're getting. Biology, up at 60% in 2001. Math, actually close to 50%. It's about 50% now. Chemistry, chemistry's been climbing up near 50% for undergraduate. Computer science going down. This has tanked, actually, unfortunately. Physics and engineering down here. So let's look at physics. Through 2010, it's been pretty stable, a little over 20% for the last decade, right? We'd like to think we're just continuing to grow and increase, but it's not changing much in recent years. This is computer science through 2007 was the graph that I could pull. So right, it's down at 13, 12, I think 12% was the most recent number that I saw. Like it's actually gotten worse in recent years. This is PhDs. So you'll notice already different trends for the different sciences where women are getting fewer PhDs percentage-wise. All fields, biology is about the same as all fields, but it's dropped from above 50% for bachelor's degrees. Chemistry has dropped, math has dropped. Physics and engineering haven't dropped that much. And there's actually studies released from the that look at, well, given how many bachelor's degrees there are, you actually have about the right number of women down the line in faculty. PhDs through 2008 in physics. Again, it's, there is this trend that's growing, but it's not growing quickly right now. Faculty, we're looking at, so associate professors at research universities, this was pulled from a 2003 data set in 2006, so these numbers have changed some. Life sciences, 32, math 22, chemistry 18, physics 11, engineering 9, social sciences 51. Sometimes when you look at these statistics and they say how many women faculty are there in the sciences, they're including social sciences. And then, especially if you're looking at, for example, undergraduate majors, when you have a ton of psychology majors who are majority women, and then you have your 10 physics majors, the numbers just completely get washed out. So you really, anytime you look at any of these numbers, you have to ask what subfields are you talking about? Are you splitting off, physical sciences, what's going on within physical sciences? Within engineering, there are a variety of different patterns. Biomedical engineering has more women. So in biology, there are fewer women faculty than women getting PhDs, and there are fewer women getting PhDs than getting bachelor's degrees. In physics, the most recent numbers I've seen were there's actually a slightly larger percentage of assistant professors in physics than there are getting PhDs. I mean, probably not significant, but it's slight. So if you're trying to talk about why there aren't women faculty members, if that's what you're having a conversation about, the explanation is going to be different in biology than it is in physics. There'll be commonalities, but there are clearly different patterns. And of course, with time and in different countries, you're going to get different answers also. This is just to talk about, well, you see some of these differences in high school. So all AP exams, percentage of women taking the tests, over 50%. And you see half the people taking statistics are women, calculus AB, drops for chemistry, drops for calculus BC, that's the one that covers more material, physics B, physics C is the physics with calculus, computer science A, computer science B, right? You see this trend. You usually hear statistics that men and women take the same courses in high school, but when you start breaking it down to the most advanced levels, you don't see that being true in physics, computer science. So this is just to reiterate the point, right? In physics, and one of the reasons why I like my job is, right, it seems you need to start before college, but if you can convince a woman to major in physics in college, she has a good chance of staying in the pipeline with the same likelihood of dropping out as men. In biology, again, it depends on what your goals are in life. Like, it's not all about academia. Jobs and employment and happiness are also good goals also. But in biology, right, the idea isn't, there are lots of women majoring in biology, but then they're not going on to get the PhD and they're not going on to continue working in biology. So in biology, you might start thinking about issues of childcare and parental leave, especially the academic path is sometimes 2 postdocs that are both 3 years. So if you think about what age you are and when you can have children, you're probably not in a permanent job by the time you probably want to have kids. So there are a lot of issues there. In physics, making those changes probably isn't going to have much impact. And I do want to say explicitly that just because you have the women there or you have the same percentage of women as men in an area doesn't mean they have the same experience. But right now we're looking at the numbers. So women are underrepresented in all sciences at fields at high levels. So that starts talking about like leadership issues and different, you can start comparing that to some other areas as well beyond the sciences. They're more severely underrepresented in physics, computer science, engineering. Starts in high school that you can see it distinctly in college major. And you do need to break down the statistics because they hide the way the numbers add up. So moving on to commonly heard explanations and compelling evidence. The way I usually organize this is you hear people still say that women are innately less talented, and talent needs to be discussed as a word, than men in the sciences. You hear that women choose careers that involve nurturing or allow time to care for a family. Maybe this is innate biological reasons, maybe this is societal pressures, but you talk a lot about choice. Women are, and you hear that women are discouraged from pursuing the sciences, whether it's unconscious bias and gender schemas that we all have, or is it active discouragement and discrimination. So I don't want to spend too much time on the innate abilities argument, but you do still hear it. Women do not have the innate talent to excel in the sciences. If you're going to make that claim, you'd better have a mechanism. So hormones these days, that's the mechanism. And if you read animals, you start getting really frightened, and like what you can do with animals and manipulate the hormones and then see this difference in behavior, it's one of like, wow, but we're not voles. And voles may run mazes and do spatial navigation, but they don't do math. So my typical response is that before hormones, right, as was the mechanism, it was believed to be sex chromosomes. Like, oh, we now know about the different chromosomes, it must be there. Before that, it was believed to be brain size. And the simple fact that the hypothesis is the same, no matter what mechanism is disproved and moved on, tells you something about the hypothesis. It doesn't mean that it can't be true, but it's suspicious. There are no human experiments. There are people, if you've heard of any of them, we can talk about what the critiques are, the sort of accidental experiments. But do see Brainstorm by Rebecca Jordan-Young. It came out pretty recently for a full critique of the biological science on this issue. And if you are in an argument with anyone, they had better at least be making the argument that it is this combination of innate, possibly just personality preferences or activity levels, combined with that leads you to different experiences, which then leads you to different accumulated advantages and disadvantages. And maybe that's how you end up with women and men making the choices and showing the behavioral patterns that they do. What is the evidence that's there? Well, you'll hear a lot about mental rotation tests that say things like, here are these two objects, are they the same? And you'll also hear discussions about the spread in ability levels, so that if you're really pulling from the top of a distribution, you might have the same average ability, but at the very high end, you'll have more men than women. Like, those are two of the most common arguments that you'll hear. Now, with this evidence, you're assuming that whatever test you're looking at accurately measures innate ability, if you're making an innate argument, that they are measuring abilities relevant to success in STEM, the science, technology, engineering, math fields. And if, again, this is innate, that it'd be great if you could come up with some theory about how this resulted from evolution. So do they test innate ability? I'm going to go with no. What evidence do I have for that assertion? Well, the ratio of high-scoring 13-year-olds on the SAT math changed from 1983 to 2005, from 13 to 1 to 4 to 1. Now, some people look at these numbers and say, and then it stayed pretty stable, so 4 to 1 is the correct number, which, sure, maybe, right? Like, you need to wait for it to keep changing. And this, the variance actually changed. So this idea of the distribution, that it's not, that it's this fixed distribution. It's not consistent across socioeconomic class. I haven't seen that much work on it, but here's a really nice paper that showed that the lower socioeconomic status kids did not show the gender difference in spatial skills, mental rotation, though middle and high school kids did. Middle and high socioeconomic class did. It's not stable across cultures. So Jewish kids score lower on mental rotations, but they're not underrepresented in the sciences. Singaporean girls outscore numerically American boys. Eskimos don't show a spatial ability difference. Women hunt in that culture. Are they enough of a separated culture that there could be a genetic cause to that? You can debate this. But it's not stable across cultures, so it's hard to be innate genetic if you can look at lots of different things that are different in experiences that point out flaws in the reasoning. And it does respond, the differences in spatial rotation do respond to training. Tetris actually has been shown to improve spatial skills. Do they test abilities relevant to success in STEM? Well, what level of talent, and it's intentionally a vague word, do you need to succeed in STEM? There's one paper that addresses this by an economist. So about 3 to 5%, you see different numbers, of our workforce is college-educated STEM workers. It depends on how you define this. But if you actually say, hold on, you're talking about the extreme end of this SAT math, is that relevant? More than half the men in these jobs and almost half the women in the STEM workforce have SAT math scores below the 75th percentile for 5% of the jobs. So, all these discussions, it's an interesting question to ask, why is there this gender imbalance on the SAT math? But it's a completely different story to then say, and that's why women aren't in science. So I'm leaving off other things that get talked about, is being risk averse a problem to become a scientist? What about inclination to avoid competition or not? Let's talk about also like verbal skills that the stereotype is women are better at. Isn't that actually beneficial in most jobs? So there are a lot of other things that you hear people make innate arguments about that we're not touching on today. So what about this question of choice? Well, what does it mean to choose if you grew up in a culture where there's no other option? You might be perfectly happy with your choice, but that doesn't change the discussion so much. And it still breaks down into innate and societal pressures. So I want to talk about the societal pressures, thinking about unconscious bias, gender schemas, active discouragement, discrimination. So right there, the question you get into conversation with people of, does this bias really exist? Does it exist to an extent that it matters? Which are different questions. So I like thinking about those questions partly because this is unique to science and some other male-dominated fields. It's very difficult to change through legislation, right? You can have educational seminars, you can talk about it, but you can't just make a rule that says you must spend the same amount of money on men and women. You could try, but you can't change the bias immediately just by making legislation. And this is also something that resonates with most female scientists in the US, that they have encountered some form of bias in their experiences. So let's look at some of the most compelling and frequently cited studies. Starting in 1976, subjects view a video of a child. Can't really tell if the child's a boy or girl from looking at him. Some subjects are told it's a boy, some are given a girl name. When the child's emotions are clearly upset, then everyone agrees on what the kid is feeling. But when it's ambiguous, so in this case there's a jack-in-the-box that springs up and the kid reacts on the second or third try, girls are more likely to be called scared while boys are angry. And you don't treat an angry child and a scared child the same way, right? So you might be raising your kids and you have a boy and a girl and you treat them equally and there's no gender discrimination in your household, but you should treat an angry kid differently than a scared kid probably. And so if your interpretations are already making assumptions, then you do end up with different experiences. And I do want to say that in this and most of these studies, the more you know about the individual subject, the person you're evaluating, the more these effects often go away, right? You use other information. It's only in these uncertain circumstances where you're really looking at a CV, a resume that you don't have any other information. You're seeing a video of a child you've never encountered before, right? That's when you have the strongest effects. So here's something from 2004. You get a set of resumes for a job that requires strong engineering background and also experience in the construction industry. So only 2 of the however many are realistic choices. One has more experience, the other more education. So if you give initials on those resumes, 75% of the time, the person with more education was chosen. This is being given to kids currently getting an education in college, so this isn't that surprising. Now, if you have the resume with more education is male, and the female has more experience, you get the same result. They're consistent. Now, if you flip it, the resume with more education was female and the male had more experience, now you see a different result. Fewer than half chose the woman and fewer than 25% said, why did you make your choice? Because education is more important. So these are people who are actually, if you only have this one scenario, they have a good reason for their choice for choosing the man because education is more important. A good reason for choosing the resume with more education. But now when the woman has more education, the choice changes and the explanation changes. Oh, well, experience is really more important. So the standards used to judge the resumes actually shifted based on the gender of the name, and the justification for the choice changed. I think parent-child interactions are really interesting, and they're not super well studied. So the one that I found interesting, right? You give questionnaires to parents and kids ages 11 and 13, and then you ask them to engage in 4 different science-y and non-science-y activities with these kids. First, you check, is there any gender difference in the children's science grades or interest? And there's not. And so parents were more likely to believe that science was less interesting and more difficult for daughters and sons. And then fathers tended to use more cognitively demanding speech with sons and daughters during the science tasks. And this is one of those things. There's also a study looking at interactions in a science museum of sort of what language do you use, and it sort of sets an expectation level for what vocabulary should you be using, what kind of causal reasoning should you be using. These are things that learning at an early age could lead you to be more successful in the sciences. If you're not familiar with the implicit association test, go take it. You can participate in active research studies at this website. What it's testing is the amount of time it takes you to associate words. So there's this training section where it says, hit the A key if it's a female associated word, and use your right hand to hit this other key if it's a male associated word, like father versus uncle versus aunt versus sister. And then same thing with science and humanities. And then you get scenarios where is this male in science? Is this female in humanities? Sort it. And is this female in science or male in humanities? Sort it. And so what they find is that both men and women can more quickly pair male plus science than female plus science. And they do this for things much beyond women in science. There's a lot of different implicit associations being tested by this, so it is a fun website to go play with. And again, you often see that it doesn't really matter if you're asking men or women, right? For the people evaluating the resumes, it doesn't matter if you're asking men or women. You actually see the bias in both cases. Stereotype threat is something that I know has been discussed on the Smith campus quite a bit this year. So quick review and one study that I like highlighting. The idea of negatively stereotyped populations underperform on challenging tests when they're reminded they're members of that group. So this came out actually very soon after Larry Summers' speech, where you give women a GRE style test. So it's a math section, verbal section, math section. So the verbal section is what you can change, and then you can compare their initial math score to their final math score. And the verbal section were 4 different cases. One that you read a passage about women and men being equally good at math. One where you read that men are better at math for innate reasons, one that men are better at math for experiential reasons, and then the traditional, stereotype threat where you trigger thoughts of gender but not explicitly talking about math. And then you take the math section again. So this is what you see. So what you're looking at is number of correct answers when you find out that where you read that there's no difference between men and women in math, compared to the standard stereotype threat, where you see this decrease in number of correct answers, compared to the genetic explanation, where you see this decrease in correct answers, compared to the experiential discussion, where you actually see the math scores, the subsequent score go back up, which it was just saying that men are better at math, but it's due to experience. And they did this in two different ways and saw the same thing. So, it gets at the question of, well, are you doing any harm by bantering around the idea that there are innate differences? And this says, actually, in some cases, maybe you are. I mean, we need to be able to have these conversations, obviously, but be careful how you have these conversations. And something I just recently learned is that the released MCAT, the medical school examination, is changing. And they just released a practice one, and there's a passage about stereotype threat on the practice MCAT. So every student who is going to be taking that practice MCAT test will actually be reading about stereotype threat before they go and take the exam, which I have to assume is intentional. But so does discrimination occur? What's the evidence? You have different studies. The ones you see most often is one from 1996 in Sweden, which is getting old at this point, and just sort of to remind you of, I try to pull from more recent literature when I'm doing this with the students in the class. 96 seems like a long time ago. So female applicants, they had a method of estimating how productive someone is, and female applicants needed to be 2.5 times more productive to be considered as competent as a man with a similar record. A double-blind review where you don't know, like normally when you submit to a journal to an article to a journal, you don't know who's reviewing you, but they know who you are. So an ecology journal said, okay, we're going to stop that. We're going to make it blind on both sides. They don't know who they're evaluating. And when they did that over a number of years, the process became blind in 2001. It was evaluated in 2007. There was a 33% increase in publications by women. And then one that I really like that, it was looking at a while ago, but orchestra auditions. So orchestra auditions where you think you hire the person who plays best, you can put them behind a curtain and listen to them play. And there's multiple stages usually where you get past the first round, second round, third round. So here's an interview process where you can actually not know the gender of the person you're listening to. And looking carefully at different orchestra auditions becoming blind in the 70s, a woman became several-fold more likely to be hired, right? And this is something that you can't really do for a lot of science hires. You can't just say, let's never meet you, and let's never talk to you. And they usually weren't blind all the way to the final round, but you could look at the likelihood that your chances of increasing from round to round increased when they did this. And this was a while ago, but the study was done in 2000. A 2012 study with actual science faculty, right? Because people start saying, if you're asking undergraduates in intro psychology these questions, is that really representative of what happens in the field? And in this case, people asked science faculty, biology, chemistry, and physics, to evaluate an application for a lab manager position. And they were told this was about feedback on resumes and mentoring. And they were asked to rate competence, hireability, how deserving this person is of mentoring, and what salary, as well as likability. And half the participants received applications with female names, half with male names that were otherwise identical applications. And so these are ratings of male students and the female students on competence, on hireability, and on mentoring. The gender of the faculty participant did not affect the responses. Yes, they sort of looked at, well, these aren't necessarily independent variables, right? So if you're deemed more competent, then you're deemed more hireable. And they also checked people's bias against women based on an evaluation of the individual. So yes, a subtle bias against women moderated rating the female candidate, moderated the rating of the female candidate, but not the male. And then there was a line about reporting liking the female candidate more, but they didn't show the data explicitly, which is also something that you often say, oh, we like you, we just don't want to hire you. And then the salaries, the starting salaries were different, $26,500 for the female and $30,000 for the male. 2012, Asking Science faculty. Again, the only thing they know is the resume. And a lot of these effects will go away as you have more information, but mildly depressing, I found. So flipping to less depressing topics, 2 case studies I want to highlight. Carnegie Mellon University and MIT. Because one of the things that happens if you make conscious changes in admissions or hiring, if you think about things with affirmative action, the question that a lot of people ask is, well, are you actually like watering down the talent, right? Are the people that you now are letting in and hiring based on these new efforts actually as good as the old group? And these are 2 of the clearest examples where I would say the answer is yes, they are just as good. So computer science at Carnegie Mellon. Carnegie Mellon is a top school in computer science, and at the undergraduate level, you have to declare your intent to be a computer science major when you apply. So they went from 7% women to 42% women over 5 years in the late 90s. And they improved the retention of women. What did they do? It's a longer conversation. Read this book. It's actually a really great book that my students regularly enjoy reading. And if you're around my age, you are in that cohort. So it's fun to watch to listen to some of the self-reporting in there. So they no longer required programming experience for admission. Right? It wasn't the sense of, oh, you have to already know how to program in order to do computer science in college, and that ruled out a lot of women who are very talented. If you do that, you need multiple levels of introductory computer science. You need to do that in a way that doesn't stigmatize the people who have no experience. You need to feed them all into the same sophomore level class. They were able to do this. And then they did a lot of outreach to high school computer science teachers teaching the advanced placement test, and said things to them like, just educated them about this, but said things to them like, don't go to AP Physics to recruit your students, go to AP History to recruit your students, because the AP Physics kids are probably going to sign up anyway already, or they're more likely to already know about it and be considering it. And also things like, that kid who stayed up all night programming and got a B, why are you encouraging him to apply to computer science when the girl who did it but didn't look enthusiastic but got an A, you're not encouraging, right? Like what's going through your head when you're thinking those types of things? And you know what? We want your girl who got an A. Send them to us. So they looked at the grades in the sophomore level courses and future courses, and just no matter where they were placed in their initial classes, they were receiving the same grade distributions. And the employment rates and the salary didn't change. Now, the depressing note is that 40% number actually dropped back down. I saw something recently that was publicized that they got back up. So, there's more conversations to be had there. For MIT faculty, you will hear a lot about this, I assume, from Nancy Hopkins. But to give you a preview of what she'll presumably tell you what really went on, they did a self-study to determine, to look at the status of women in the sciences and engineering at MIT, and in 1996 and 99, and they determined that women were paid less and had access to fewer resources, enough that the administration immediately made changes to create equity. And hiring practices changed. So what did they do? They failed a search. Like the administration would come in and fail the search if there were no female applicants interviewed, qualified female applicants interviewed. If you pool slots to have multiple searches at once, you can actually increase the chance, because if you only have 20% of women getting PhDs or fewer, and you only hire one person at a time, you shouldn't be hiring a woman every year, statistically speaking. When you ask for people, like if you just call up the great people in your field and say who's in the pipeline that we should be interested in, explicitly add what outstanding female candidates do you know, you get a different set of names. And then you end up hiring some of them. Overall excellence, more important than the specific field that you said you really had to have. Explicitly go try to find candidates who might not have otherwise applied. And then once they were selected, work really hard to make sure that they come. Again, are they as successful or more? Enough time has gone by. Like, what do you want to measure success by? Presidential Medal of Sciences, National Academy of Sciences, right? Like, these are prestigious awards. And so what percentage of women who were hired after this time versus men received these prestigious awards or higher for all of these? You know, the numbers aren't big in many cases, but, you know, I'm going to go with just as talented as the old pool. So what can we do? At Mount Holyoke, one of the things that we try to strive for is an academically rigorous program that is friendly and welcoming. So I haven't talked too much about sort of what's considered female-friendly and inclusive teaching. But things that we try very hard to do, use active learning techniques based on physics education research. We provide hands-on research opportunities. There's evidence that shows that one of the best ways of getting women and minorities to persist in that major is to give them hands-on research opportunities at an early age. We have a lot of peer mentoring with older students working with younger students in the introductory and sophomore level classes. We encourage collaborative group work. We have a lounge area near the offices that have computers, comfortable chairs, a kitchen, hot chocolate, popcorn. We have social events, seminar and workshop series that both mentor students in the careers and bring in diverse speakers. We target topics that are important and relevant that the students say they care about, for example, renewable energy. And we have a diverse faculty in our department. More generally, and again, this is now going to go into areas that I didn't talk too much about. Well, simply requiring 4 years of high school math and science might be a good start, because then you won't get as many differences at the high school level. Now, are requirements the best way of accomplishing things? That's a different discussion, but it would be an interesting thing to try. You need 4 years of English. Most places you don't in science and math. Engineering and computer science are fields that most people don't really know what they are at very early ages. When they get to college, they don't really know what they are. Provide female role models, encourage women to do science, tell them men and women can and do go into science. Emphasize that engineering is about society, improving society in many cases, the role that collaborative work plays in engineering, that you're working in teams. Improve parental leave policies. Create this collaborative, supportive environment in undergraduate classes and the workplace. Change your hiring practices. And what I think is most important is really, as an individual, redefine your notion of what a scientist is supposed to be and how you identify talent and passion, right? The tendency is, if you feel like you're successful and went into it for the right reasons, that you relate to others who are like you and can see why they'd be good in the future, and then you encourage those people. But in reality, it takes a lot of different backgrounds, a lot of different types of people who have the different reasons and may express their passion differently, may express their interest differently, may have completely different motivations from you to go into this field. And if we all started identifying this talent differently, then we would start just pulling from a much bigger pool and just being much more inclusive in what we're thinking. So that was a lot of information pretty quickly, which means I probably forgot to tell you some things I intended to. Here are some of the references I've been mentioning. This is a collection of essays from 2007 that really, almost everything I touched on, there's somebody, a researcher in that field who's respected, that has an essay that's addressing sort of what's really going on right now in that area. Unlocking the Clubhouse is the story of Carnegie Mellon. Brainstorm is the criticism of a lot of the science of sex differences, and then throwing on Why So Slow from Virginia Valley, and if you want to learn more about gender schemas. There are references throughout the whole thing. I do have a website with my syllabus from the class. I ask that you don't assume that because I have the students read it, I am saying it's a good paper, right? It's about discussion, not necessarily about reading the great stuff. But with that, I would like to know what you would like to talk about and any questions that you have.